The three laws of robotics. First, a robot must not injure a human being or, through inaction, allow a human being to come to harm. Second, a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. Third, a robot must protect its own existence as long as such protection does not conflict with the first or second laws. Welcome to la Nova Mobilitat.
Hello. Grüezi miteinander. Welcome Zurich to la Nova Mobilitat. We are very proud to be here. Thank you for having us. It was a challenge. Even the train trip from Munich to Zurich was a challenge. It was 2.5 hours delayed. So we just arrived right on time and we just set up everything. So please, I hope you can hear as well. It's not too loud, it's not too low. And we can start as soon as Miquel joins us. Miquel, you want to join us? Okay, everything. We're recording the podcast today. We're recording video and audio, and we will publish this special podcast online on Spotify on our podcast, let's say, channel in the next weeks. And that's why Miquel was checking. Miquel, you're a little bit dark.
Like always, in the podcast, usually I'm the dark one. So it looks like it's a...
So you always make the introduction. You're very fluent in this introduction. Who are we and whatever.
I made a little script, but I forgot about it. So I'm just gonna, make it up again. So I don't think all of you know us as a podcast because we do it mostly in Catalan, so it's quite niche. So let me explain a little bit who we are and why are we here. So we started in 2022 with a podcast called Nova Mobilitat, like new mobility. We wanted to touch on EV, AV, so transformation of mobility industry. Martí is a battery engineer. Oh yeah, so forgot about that. A battery engineer at BMW. So he touches mostly on EVs, on electric vehicles, on battery technology, on powertrain. And my experience is mostly on autonomous vehicles. So I touch on robotaxis, autonomous cars, ADAS, digitalization, software-defined vehicle. So last year I was telling Martí, hey, it's the year of the autonomous vehicles, and he was, okay, stop about that, you are so always talking about this. And then I told him, but now it's physical AI this year, so it's robotics, and he seems like he's more interested about that than only autonomous vehicles. And he came up with the idea to come here to Zurich because it's hotspot for robotics. It's also like to make a connection, so it's the first time for us to do a live podcast in a city where neither of us lived before. So we did it in Barcelona, in Stuttgart, in Munich, where both were, so at least one of us lived before. So it's the first time here. So happy to have you all here, that you join us in this really cool place that fun. So thank you.
Thank you.
Yeah. So what do we want to talk about today, Martí?
Well, robotics, it's a big word. It's a, let's say, very extensive field, and we have seen in the last time we both come from, let's say, a little bit from automotive, and we have seen a drift, let's say, in the last years, months, in the industry, in the not only in European industry but in the worldwide. We see a drift to several fields, maybe some defense, but also robotics, where there's much more growth, much more, let's say, speed and development than maybe in the old automotive industry. Let's call it like this. Although robotics, it's actually also quite old. Not that old like automotive maybe, but it's also quite old. And we're talking about also about one industry which has been developed in several countries, of course, but I wanted to say that the word robot itself, it's actually a European word. It comes from a Czech how do you say, writer, who was in the 1920, I think, years, wrote a play role. And so since then, the word robots, it means actually slave, but it has been developed until what we know today, what are robots. And since both of us, we're not into robotics, we're not specialists in robotics, we're very interested in robotics, and that's why we wanted to do it from our podcast La Nova Mobilitat, but we wanted somebody who is a little bit closer to the robotics, and that's why we invited Enric Galceran. Enric, welcome to La Nova Mobilitat.
Thank you, Martí. Thanks for having me.
Enric, you have impressive CV among several, actually not European but American tech companies, but as I know, your knowledge on AI and machine learning, it's deep in all your roles. And though there's, let's say, this kind of physical AI, the application of AI, who's everybody talking in the last years, we're talking now about robotics, physical AI, which is the let's say, the mechanical implementation of this artificial intelligence. Could you give us, let's say, a first very rough overview? What do you think? Which are the new trends? Or Miquel, do you want to add something before?
No, maybe just touch on a little bit on your experience. So you worked on AVs at University of Michigan. So that's what's an area where you touch on physical AI.
Maybe AVs, it's not a word for everybody.
Autonomous vehicles. So I will repeat it many times. So AVs means autonomous vehicles. And now you are more in the consumer type of usage of this. So maybe if you start walking us a little bit through your background, would be good.
Sure. If we focus on the AV part, or
don't be afraid of the microphone.
I like to say self-driving cars, just maybe more understandable. Started working in the area back in 2013-14. Maybe for reference, the year 2020 was kind of a goal for the industry back then, of when we would have already autonomous vehicles that would take us from A to B, or like to dinner without any intervention.
The robot taxis.
Exactly, yeah. Those would be already everywhere. So we're using that goal very extensively, and spoiler alert, I have seen it passed behind us without that being, let's say, a widespread reality. So yeah, my connection to the self-driving car space started at the University of Michigan in early 2014. I joined there as a research scientist after graduating, first time living, let's say, for a long time abroad. I worked for, or joined between the university and Ford Motor Company, developing their first initial research project, let's say, on developing the technology. After that, I came to work for ETH Zurich, the one company that you can call European that I have worked for, or organization.
That's one of the strengths of European talent research. No, I mean, European universities are very well known worldwide, so that's actually one point for you.
Very much so. There's very, I agree. There's very well-known ones in Lausanne and in Zurich, in Switzerland in particular, and there's many strong ones throughout the continent, London being another example. There's also strong ones in several other countries, including the Catalonia region. I continue working on robots, and then I work at Apple for almost 8 years. I can't talk too specifically about what I did there, but let's say it was in a similar space, developing autonomous systems for personal mobility. And only more recently, I have started working at Google on, let's call it, one part of self-driving cars or one part of AVs. The two parts would be understanding what is the world around us and where the car is located in that world with precision. the other part would be how to go to dinner or to our destination. So I'm focusing on the first part because it's applicable now to many existing products that do not require a self-driving car or robotaxi to exist. You can use Google Maps every day, who uses exactly that technology, and that's what I'm focused on right now.
Thank you.
Let's get directly to the topic. Humanoid robots are right now like really hyped. Like it looks like we're going to have an Optimus robot in the next couple of months helping us with daily tasks. What's your view on that? Are humanoids really that close?
I guess I would say I don't have any skin in the game. I not have any startup or investment to support throughout my view. And
maybe we'll find one here.
Possibly, yes. In my case, I like to be careful. I guess I've been enough years in the space to see the year 2020 pass behind us. And if we're looking at 2030 to use a concrete date as the year when we might have a robot doing our dishes in our home or picking up our trash or doing our chores, I would like to see it, of course, but I would like to be careful. I think there's been a lot of investment and hype around this technology, possibly kind of piggybacking on the success of large language models like ChatGPT, Gemini, and the like, that have started creating a lot of interest and have started solving or creating a lot of value for consumers, for people. But drawing text on a screen without any stakes for what happens if that text is wrong, as opposed to if you take the wrong turn or go into the wrong place with a robot, are very much different problems. And so despite there's been impressive progress in the last couple of years, from that to creating something that really solves problems for people in their day-to-day, it's still probably a ways away in my take.
So getting the capabilities that today large language model has, getting some world models, or I don't know how we call them, physical models, it's still, how far away you think we are from that?
I would imagine, or my view is, those ideas are still in the research stage, and there's several organizations and companies pursuing the idea of creating some model that can be as useful in the real world as a large language model is producing text or generating text. I don't think that anybody has seen yet that the same technology obviously translates, especially if you look at creating some robot that can do anything, as you might need to have or to fulfill the promise that the robotic humanoid body promises to you, which is, okay, it looks like a person, it probably should be as capable, as competent as a human person. And so fulfilling that is something that no large language model can do today, and no trivial translation of a large language model to act in the real world can do in a general sense, or in a sense that creates value, despite some localized impressive demos that you can see of, I don't know, robot folding something complex or putting a paper note inside a wallet, for example.
Gotcha.
Well, one topic which we are going to discuss later on also with the interviewees is there's almost in every second house there's a Roomba robot, vacuum cleaner, which is also a robot kind of. Now we're seeing these trends in humanoids, and these are like two different applications. The one is a very specific robot for a very specific, how did you say, chores, no? So some activity, and it's clear what it has to do. It has to vacuum up. And the humanoids, they should be able, let's say, to do every single thing, like from taking out the clothes from the washing machine, but also the wash disher, tidying it up, or I don't know, any chore which we humans are doing every single day. What is your approach in, like, okay, is it better to have single robots for every single chore, or one robot which is maybe not at the beginning, it will have to learn, definitely, but we don't have to change completely our ecosystem, let's say our houses, in order that there are much more robots inside.
Yeah, you mentioned the Roomba. Very much.
The company went bankrupt, by the way. The room.
Only recently, sadly, yes. But still, more than 25 years after it was founded, it's still we roboticists have come up with as a consumer product. It's still the major success story that probably everybody has seen in one house or another. I'm also a fan of dishwashers because you mentioned them. They solve a problem and they do it very, very well. So I would imagine that we'll probably see machines, call them robots, call them appliances, that will solve those types of localized problems before we can find or create something that fulfills the promise of a humanoid form factor, if you want to talk in those terms. I would say that there's probably opportunity or the middle ground for me between an appliance and something as general as a humanoid can be somewhere in the industrial space, where traditionally you have seen robots that solve the problem of, or one of many problems of interacting with people, which would be safety, by basically putting robots or the big robots in cages and separating them from people so they cannot harm them. So there's a lot of applications that work using these types of giant robot arms that the car industry
soldering and so on. Yeah.
Exactly.
Welding
Painting,
robots.
welding, all those types of tasks. Maybe packaging, maybe separating items. There's probably opportunity for something in that middle ground that might look like a forklift or something that can move around rather than being in a cage.
AMRs, is it called?
I'm sorry?
Autonomous mobile robots, so wheeled robots.
Yeah.
Miquel is always telling me about this kind of.
I'm forking professionally to this area, maybe because the margins in automotive are a little lower than in robotics. So yeah, starting to learn.
Yeah, I think there's opportunity to create business value there and solve problems that compel manufacturers, businesses to actually incorporate this more advanced technology. And because the tech needed is already more or better understood, like being able to create a map and being able to localize inside the factory is something that has been deployed and developed at some level. We have never seen a humanoid act on its own, creating value. So that might be a possibility, a form factor that is somewhere in between, maybe it just only moves in constrained environment or in limited environment, but it does enough useful things that people want to pay for it and have it. Yeah, that's what I would share.
Thank you, Enric. Thank you for this overview and this short introduction. Yeah, just enjoy the interviews which are now going to follow. Thank you very much.
Sure, I'll do. Thanks very much.
Not so quickly. Now you are part of the team, Enric. So now it's really welcome to Nova Mobilitat.
I'm honored. Thanks very much.
It's like soccer player.
Yeah.
You hold it
For free.
So applause to Kateryna. Welcome to Nova Mobilitat. Yeah, I should take it from him.
All right.
Hey, Kateryna. Welcome.
So let's start a little bit with your background. I think you come from business in health, now in robotics. So walk us a little bit through your academic and professional background, Kateryna.
So currently I'm working in ANYbotics. That's a spin-off from ETH that is producing here in Switzerland industry inspection robots, quadrupeds called Animal. Prior to that, I was working in Hokoma that does neurorehabilitation robotics devices, and over 25 years have been spin-off from ETH and created the industry of neurorehabilitation robotics itself.
That was my journey in Switzerland. Prior to that, I was working in London, Hong Kong, Dubai, and New York, mostly with startups and scale-ups in different industries, health, fintech. My background is mostly in business, but I conduct also computer science and a PhD in social science.
Impressive.
You are also a chapter co-lead of Women in Robotics in Switzerland, right?
Yes, it's 2.5 years since we started Women in Robotics chapter. Most of the events in robotics looks more or less like this one. Representation of women is very low, and we're trying to change that.
So we identify role models, mentor younger professionals, and collaborate with robotics companies in Switzerland, bring people to understand how the robots apply for preservation by Zurich and Greater Zurich area. So whoever is from Zurich, it's gender inclusive community. Please join us and follow us on LinkedIn.
And you are lecturing at ETH also?
I'm lecturing in HAVZ, so it's business administration school here in Switzerland for advanced studies. So professionals who did their studies already and would like to understand more about future tech or digitalization are coming to those 6 months programs, and the topic that I'm lecturing there is robotics and physical AI.
So maybe with your experience in health, or how does it translate now to robotics, or what lessons through your career you are implementing now in your roles today?
So regarding the healthcare industry, as I mentioned, Cocoa is a producer for neurorehabilitation devices. It also has hardware and software. And what I learned from working there, that in most of the cases, it's not robot that creating a problem. It's a system that you need to fit in. There is electronic health records, there are interfaces, and 70% of work now with industrial robotics, I see as well, is on onboarding, explaining and bringing the awareness to what robot will do, what are the tasks, integrating with existing systems. And only if that is managed well, the project will be successful. So you don't bring a robot. Robot is not solution itself. You identify the problem and then you're orchestrating the changes in the system. And for healthcare, in case if it's more than 10% of change that needs to be done on software level, for example, it's no go, it will fail. And what I see now, we separate greenfield and brownfield. So for the brownfield, most of the industrial infrastructure objects, it means that they don't want to change more robotics, nothing. So you need to work there with existing conditions. With animal, for example, we can hold the stairs that has 4 legs. It's very stable and works in the very, very bad environments for humans. There is hot or cold or dark or a lot of gases or a lot of pollution. So it makes a lot of sense to bring robot there. It's doing job that humans should not do in any case because it harms their health.
Like maybe a fire or a house fire where the firemen before they go in maybe?
No, our applications are more on the oil and gas, offshore platforms, on the chemicals where something is explosive, on metals, utilities with electric arc, so those kind of applications where you need to stop the production line for human to go there and spend, but robot can do it 24/7 without any support.
So dangerous environments where men and women cannot.
Humans should not be there. I have been there, so as a product manager, that's my main role. I was going there, and that's not the place where anyone would like to be and work long term. If you can collect that data that humans are now collecting with sensors, remotely with robot, analyze it and do it from the office, that would be everybody's preferred choice.
So part of your role as product manager is to identify the use case and see where's the fit with the technology you have to use to scale, right?
Yes, and also to be able to calculate the ROI, because we have now big hype about humanoids, but quadrupeds, for example, they don't need hype, they need a budget. So you need to realize where you save money, where you bring visibility of the assets that are actually working well, so you don't need to spend time and inspect it. It's a lot of things that is happening there, and if you have the data information in intervals of 1 week or 1 month, but with robot you can have it real time, that's a preferred option for most of the critical infrastructure objects.
Miquel, let me ask, what are the specs differentiation? I mean, the quadrupeds, I imagine, like we have seen maybe some videos, it's like a dog, let's say, let's call it like this, animal, like this, and then you have this kind of humanoids from 120 centimeters height until 2 meters height, something like this. Would look like a human, has 2 legs, 2 arms, and can walk and so on. What are the, like say, the differentiation on characteristics? What can the one do better than the other one?
So currently, all the robots that you can see in industrial space are mostly those autonomous mobile robots or stationary robots or mobile manipulators. You do not see yet a lot of humanoids there. So comparison is difficult to do, and the logic behind, for me as a product manager, is always to ask why. So what, for example, Quadruped cannot do?
We have a 20 times zoom camera, so like if it's the high thing, they can measure thermal, acoustic, other images. If it looks like human just for the phonics to work there and it's less scary, that's another thing. But from the use case perspective, the vision for humanoids is quite far, that they will be able to manipulate the hand like we do, so they can turn the valve, for example, or press the button. This is something that inspection robot, at least from ANYbotics currently, is not doing. But it's a lot of value already with its detection. When robot can go in the perimeter during the operating hours, after operating hours, can be on the offshore platform, whereas no humans may be in the middle of the ocean with the bad weather and check what is happening. Downtimes in those objects of these assets cost millions. So it's very easy to understand the value of such a robot. We're also talking about mining facilities. They can be very far for engineers, for example, to go and check something. So meanwhile, we not to go there twice or 3 times, robot can check what is wrong, what is overheated, where is the leakage of gas, and then they're more prepared. Humans can come and fix the problem.
And these are robots, the ANYbotics one, that are already on the field. I mean, probably you cannot say the number. Is it something confidential? But there are some use cases that are already.
There are multiple use cases. From 2022, we have those robots on the field. We are co-developing together with our partners and clients.
We are not in a pilot phase anymore. So that's a commercial product with different business models where customers are buying it or rent this robot as a service. It's available globally, and that's difficult to compare with any other humanoid, because I can think there the objects. I do not see humanoids there. So I see what our robots are doing, I see the potential, but I don't see the comparison yet.
And before with Enric, we were talking about the next step in the software side. So going from LLMs to world models, this would enable other use cases. But what about the hardware? What about the energy density in the batteries, the dexterity for the humanoids, or the other fine motion? Is the gap similar than we see in software? Is it farther away to get?
So robots are kind of in between physical AI and hardware, right? Because they need both. You cannot just have hardware, you need to have a brain. Brain is developing fast, and actuators, batteries, you mentioned, speed of the development bar is something slow. Like hardware is complex. Hardware has so many regulations that need to pass. They have all the stage and systems and machinery regulation that is coming in place. So in this case, in the company where I'm working, we have a priority. It's not urgency, but reliability, safety, compliance that really matters. So for our customers in energy, in chemicals, and oil and gas, they are ready to co-develop, they are ready to wait until we bring the hardware that fixes their problem. Then the
robot that will lead the innovation unit just to show that they are innovating something. They really have real problems that we have identified. And now iterations after iterations, we're updating next versions of the robot. We have robot that is there already for more than 4 years. We have new robot that is coming for alien zones and explosives. And it takes time. There is no way to go around. Like when I'm hearing all these commodity stories that we will just get robots from China and then we will put our software and this is our game, I don't believe it. For industrial infrastructure, I'm talking to the customers. They are ready to wait, but they want Swiss quality.
On time.
Like your train today.
Like my train, not. And it was a Swiss train. But anyway, I think that's the safety. It's an important topic. We have been seeing a lot of dancing robots in social media, Chinese on the Chinese New Year, really impressive movements and so on. But also we see every now and then some, let's say, also some videos where we see those dancing robots when suddenly they fail, they fall, and they harm somebody in the public. So I mean, as you said, it's hardware and it's not lightweight usually. So if one robot makes a wrong move, it can damage a lot. What are, let's say, which kind of, I'm completely like coming from the automotive industry, which kind of standards there are in order to make this compliance?
Yeah, so the thing is that innovation is faster than regulation. And we are trying to collaborate, for example, last year project together with Canton of Zurich on the sandbox, how to be prepared for EI/EU Act, how to be prepared for Cybersecurity Resilience Act, how to be prepared for machinery regulation that is changing from machinery directive, how to be in the space where safety really matters and is done by design. And that's still a big question mark, right? So we are taking the existing standards and we're trying to adapt them to robotics, because that was part of the solution that was not there before. And it's quite difficult to put a cage around the robot if it needs to expect a couple floors. In our case, the stairs are there for making happen in different floors, like humans do. So it's very important also to onboard the users and call them bystanders, but people who are not using this robot but working in the same not structured environment, to keep their distance from the robot, to know where is the safety button to stop it, not to use the stairs, because one part of the robot is about 50 kilos, another will be 80 kilos, and that's quite heavy if they take the sledging of you while they're walking. So all that measures are coming as we talk, and we need to be able to predict them first, to be able to sell those robots, but also to adjust these regulatory bodies, these auditors, this whoever is there, that we are safe. And I believe that we are doing it much better than China is doing. So from that perspective, for this critical infrastructure industry, many of Chinese robots, even if they're cheaper, is no goal.
So China has the capacity, the production capacity, US has the software and the semiconductors, and Europe has the safety.
Quality, safety.
Quality would be?
Quality, safety, regulation. We need to understand
Perfection.
how to play that card. I believe that for some industries, and in these industries ANYbotics operate, the full cycle is important. It's not that they will take hardware from China, software or AI from the US, and I don't know, whatever parts. It's not easy to implement if in the hardware you do not have the safety button. Like, you can add, of course, a lot of things, but would a Swiss company then claim that this is what they did if they do on the software? We can see in our scene here, more and more software companies appear. They start with some Chinese hardware, but with the time they still create something on their own. So to test the prototype, this is what I was doing also last year. I was considering many different applications for our robot. And some of the options to test it out was to take some parts from Chinese manufacturers, but it doesn't mean that people use it for mass production. For testing, for use cases,
that could be good. Maybe later for consumer use there you need to lower the price, possible, but for industrial infrastructure, no go.
Maybe last one on social impact or so also with your social background, or social science background, like the story we hear a lot about robotics is, it happened many times in history that new technology comes, there is a transformation, there are new jobs realized and say, okay, there will be, someone that needs to service the robot. So the people now doing like low-skilled manufacturing jobs can reskill into other kind of job. But this is, I haven't myself really seen data on that, on how this is happening today with the robots that are already in the plants and how it's projected. Do you have any insights on this, Kateryna?
Yeah, there are many countries where is the country policy, including China, is robotization. More and more countries are coming with such policies, even in Latin America, where they would like by 2030 to have at least 50% of workers replaced, not because of the crisis, not because of immigration policy or whatever, because of the health issue. I'm working with industry, right? And what I really believe that those people would need to be retrained. And I do not know where we will take and find all those trainers. That's another category of people that will need to explain them how to understand data, because decisions will be on the people heads. We can make some triage with robots on the images, but then the decision to stop the flash, to press the button, to close, still need to be on something. The robot will not have responsibility. You cannot go back to the developer and tell the robot did something bad. Then maybe the developer is already in a different company. So it needs to be on a human. And we will need to have less human, because less human will be able to comprehend the data. So I'm predicting kind of a social crisis there. I do believe that these people will most likely will be in a position where they will not have choice. They will need to proceed this life of learning. And I hope that everybody would be able to do that and comprehend that, and the benefit of having robots will be equally distributed. But then in that I'm very much in classes that will not happen. So we will see the next 5 to 10 years what will happen. And in many countries, including China, that means that those people will lose their jobs.
And at the same time, we have been seeing in the past, and we will see in the future, many people getting older, and I think the industry will still need a lot of workers, and if it's not enough, maybe the robots are one of the solutions.
Yes, young people in those environments that I'm describing do not want to work, so shortage of workers is one of the main reasons why those robots are created. That's true, and so many people work there. And hopefully new people have those skills, and it's introduced in their curriculums and the diversity at every level, because every company in the future will have some presentation in some way. And it's not my words, it's words of the CEO of NVIDIA, and he knows better.
Then let's get prepared for the robots area, and thank you very much, Kateryna, for your insights. Well, just 1 second, Miquel. You have it already?
So, if I have a present for you, you can have like your morning coffee or hot drink with Nova Mobilitat. So, thank you so much.
Thank you. We just talked about hardware. Now we are going to talk about software also with Thomas Tamfel. Welcome, Thomas.
Hi.
Hi. Thomas, tell us a little bit about your role at ERNI as a head of AI. How do you say it?
Data and AI service lead, yes.
Okay. So let's call it head of AI, okay? No.
Yeah, my role is actually...
Don't be afraid of the microphone.
Okay. So we are actually a software company. We build custom-made software. And so my role is there actually now to talk to customers to figure out what is their need. Thank you. what they need, what are their problems, and how AI and software could actually solve it, and what is needed in order to do that. So it's a lot of customer interaction.
And as we were preparing the interview, I said, okay, Thomas, but tell me, there is big robot companies. There are a lot of startups, big robot companies. I can remind here Zurich, ABB, but we have also like KUKA, like many big robot companies. And I say, why do they need somebody who has, let's say, software consulting to program those robots? Do they don't do it themselves? What does it? What's the service which ERNI offers to those companies and to the public, let's say?
Sure. So nice that you mentioned ABB. Actually, we worked with them. We had a robot arm from them, so we programmed on it, and we did a couple of demos with them as well. The idea is that a company like a huge company, they have a lot of use cases, right? It's not only one case, and so when the robot comes, it can do a lot of tasks, but maybe not very specifically that task that it was intended for, and then the company needs it. So you need to reprogram it, like going for the task, but you also need to test it. So we've heard before, actually security is a huge problem. So when you do something like this, you have to test it, you have to secure it, you have to look if the requirements are met, and so ERNI helps also with that. So we are not only providing code, of course we can do that as well, but we also provide like testing systems, requirements, the people, and we try to actually put the software in the same way.
Just let me ask, Miquel, the recording is going on, no?
Yeah.
Okay.
Last time I checked it.
We are humans, we're not robots, and we just try to avoid failures. Just let me check the questions. But as we were planning the interview, you said, okay, let's talk about some specific application you have been working on from ERNI in the last, let's say, months. What would you explain? What is it? Let's say we just heard the quadruped, the animal of ANYbotics going to gas platforms and so on. What would be, let's say, an example what you have been doing also?
So yeah, it would be like industrial robots, basically large-scale robots, like in the lab.
But like an arm, or
like an arm, or even like a conveyor belt, where you actually put your little probes on, and then you can actually look where they are, pick them up, put them in another place, something like this. So we've done those kind of things, but also we build actually the data platforms that are needed for those kind of systems to run. So for example, we had a customer, they had robots, they were scanning parking places. So they were actually looking at the plates from the cars, and they were checking if they paid the parking ticket or not. And if it was not the case, then actually they called the
So police robot, more or less.
It was not a police robot, it was actually from the company that was there to give the security of the place.
Okay.
So stuff like this, or then maybe also what we actually really working on is right now, how can we code with AI?
Okay.
And how can we actually interact with robots in a more humanoid? So imagine you have a lab and you have to every time you program, the robot do something else. So the human takes like 2 or 3 days, comes there, has to write a lot of code, and then it fails, it works, it fails, so you spend a lot of time. And so now the idea from a lot of customers is, what if we can interact with chat? You might say, you're now moving this dispatch from here to here, but what about taking this batch and moving it there? And you simply tell it via chatbot, and then the AI in the background can start coding. You have large language models, you have various agents that understand the robot, the hardware, and understand the software, and then you can start coding up, and then a human, actually we talked yesterday already, the human in the loop, what we call that, has actually to take the decision if the software is built, and can then run the program. But this cycle makes it much faster.
Yeah, heard it, or I used to work in software in the loop, in hardware in the loop, but I didn't know about the human in the loop, which checks if what the robot is doing, it's the right thing, no? I understand?
Exactly, it checks if it's the agent or the AI doing the right thing, the robot doing the right thing, so you have a human in the loop at multiple places. So for example, also for regulations, this is important that the human already was the right person, but the person saying, yes, please do that, and not let the AI do the complete process.
Okay. As you said, let's say in the past there was a lot of programming of the robots, and the robots, which we know in the industry, they used to do, let's say, some repetitive work, always the same, very precisely, but always the same. And now we see, let's say, a change in the robots, that they start to have more computation, more let's say, neural networks, more kind of intelligence, yeah, and they can. You don't have to tell them exactly what they have to do. They can learn a little bit. Is that something what you are also kind of programming?
Yes, we are doing that as well. So we have a couple of cases where we did exactly that. The point is industrialization, right? It's not that every company has those kind of robots or will deploy them tomorrow. That's very difficult. So right now this is more proof of concepts, R&D work. But yes, of course, there are a couple of cases where you have this. A little bit lighter versions that you have in productions are maybe, imagine you have again an arm in a lab where you take the little packages, little bottles or whatever, so that you don't have to program it precisely to exactly attach a camera. And then you can say, okay, please focus on the errors or center on the middle of the package, and then the robot does actually the thinking for you. So you don't have to say exactly at that position you have to be. And this kind of things we see very, very often. 4 weeks ago I was on the Embedded World, 3 weeks ago, and every second booth had actually computer vision on an embedded. So this is a topic that's really coming, and we see it everywhere.
Okay, and at the same time, so I mean, we have been seeing also that there are like robot companies, but there's also suppliers which are doing maybe like only the part of vision part, or only the tactile part, or only the application, the software application. Where do you think that it's going to lead this kind of industry structure? Is it is it better like this, or do we need also some vertical integration?
Very good question. I think actually this will be the same moment as with ChatGPT and agentic systems. So I think for a long time myself I thought, okay, the AI is smarter, we need larger large language models from the GPT-3 to GPT-5, maybe 6, 7, whatever. But actually the biggest change came from integration, working together. The models didn't have to become smarter, they just work smarter together. That's where we see the biggest advantages. So I think the industry will really profit from the fact that if you manage to have all these different disciplines working closely together, and maybe even autonomous, so having multiple agents working together, having multiple ideas coming together, this will be the biggest change that we've seen so far.
Mm-hmm. So it's a huge, let's say, huge work, because of course everything in one hand, it's not easy. We have been seeing many collaboration between, let's say, one of the biggest, let's say, AI computing winners, which is NVIDIA. No, we have been seeing a lot of companies, robotic companies in China, and we see still, let's say, a chance in Europe. Is there a chance to work all of them together among the whole, let's say, continent struggles which we are having now with wars, with tariffs everywhere and so on?
I mean, I would like to say yes, but I'm not a politician, so I cannot answer that question. Yeah, of course I would like to, and I think the industry and the R&D departments, the universities, they're really trying to work independent of location. But if that ever happens, I don't know.
Okay. You as a company, ERNI has headquarters here in Zurich, is it? But they also have, let's say, a location in Barcelona. Where do you have geography other places where you're working were?
Yeah, so we have market units actually in Switzerland, Germany, Spain.
Okay.
Also in Manila.
Okay.
And we have also
Philippines.
shoring,
Yeah.
yeah, exactly. And we have shoring units in Romania, Slovakia, Spain as well, and also the Philippines as well to have just for shoring. So we have different kind of structures, market units and shoring.
And do you think it's efficient, this way of working with several locations? Where do you see strengths? Where do you see challenges?
I have actually to say that I work very closely now in 3 projects with our Manila colleagues.
Okay.
I'm amazed actually how well it works. I think since COVID, when we got really used to use Teams, use the internet for communication, using AI tools, it has become so easy to work cross-continent. And I have just positive experiences again. So I think this will be even more in the future, even more AI fits role. You record meetings, you summarize meetings, you don't always have to be there. So the stuff like this will just become bigger.
It's also something we learned during pandemics. You can do a lot online, but at the end, we also think that the face-to-face, like today, it's also very worth. Maybe looking ahead, kind of outlook. What do you think? What will come the next 5 years in robotics and AI? What do we want to? What do we need to expect in the next years to come?
So I think one of the biggest challenges will be actually to make the systems work together. So I think we should not think that we will have one robot that solves everything, right? I mean, that's something that is nice, would be cool, but I think that's the old is very far. So we think the real change on you have specialized robots that work together and become smart so that they can exchange data, that they can somehow coordinate themselves. So this will probably be the next step. So that we can go away from one robot solve everything, like actually we have multiple robots that work smartly together, and connectivity will be the next big thing, I think, in more robots.
Great. Usually I'm also doing this podcast together with Miquel, but I'm missing him. I hope he can join again. Thank you, Thomas. Thank you for your insights, and thank you for this overview on what ERNI is doing.
Thanks for being here.
The job of Miquel is giving you a mark. It's up to him. Salvador, you've enjoyed me. Miquel, it's okay if I 30 seconds. Some music. I can put some music. You can play some music because Salvador is also a musician. I just wanted to stay a little bit. But I need to explain that in the program we will have a small change since Peter, who is the director, the editorial director of the Engineering Association in Catalonia. It's fine. Okay. Don't touch it. He just explained that he won't be able to join today. He had several other meetings and he couldn't leave Barcelona today. But still we have, let's say, a great representation of the Catalan talent in Switzerland. And that's today where it's one topic which we're going to discuss with you, Salvador. And also about your research field of microrobotics. Again, just let you know when we're. But we keep just on chatting, okay? 1, 2, 1, 2. We're good. I think we can follow.
All right.
So, with all of you, Salvador Pané, professor of the Zurich ETH, I don't know how to say it in English, ETH. Welcome, Salvador. I don't know how to manage.
So now we're changing a little bit the topic, huh? So
I don't know. I was talking
focusing on to different specialty.
We're going to bigger to smaller robots, and I was discussing with Salvador. Salvador, just explain your research field is microrobotics, nanorobotics. What I was discussing, okay, does it have to do something with AI or not? What is microrobotics? What do you do?
Okay, so first of all, micro and nano robots are small-scale devices that have the ability to swim through fluids using external sources of energy. Mm-hmm. And one of the energies we use in our lab is magnetic fields, okay? And if you want to understand the analogy in robotics, you imagine a robotic arm where your input is the velocities of the joints. You have an end effector, which does the task. So in the case of magnetic microrobots, you have coils. Mm-hmm. The input is the electricity, the currents that you run through these coils. A magnetic field generated, this will be the arm, mm-hmm. Okay? And the end effector is the magnetic object that ultimately will do this task. And as I focus on medical applications, one of these tasks, for example, is to deliver drugs in tissue. Why do we do this? Because we want to deliver drugs only where they are needed.
Inside the body.
Exactly. We want to avoid injecting drugs and then distribute them systemically and cause side mm-hmm. effects. So the task of the robot is to minimally deliver, to act as a minimally invasive tool to deliver the drugs in the tissue that is needed.
Okay. The tissue is
tissue cells.
The cells.
For example,
okay.
A tumor.
Okay.
A tumor or a stroke. Mm-hmm. A stroke in the brain or clot in another part of the body.
Okay, and that means what you said. So it's not the robot system. It's not only this small
correct
part which is delivering the drug.
Correct. So we call the microrobot usually the tiny device, so to make it more understandable. But from a robotic perspective, the robotic system is everything. The computer that controls the coils, the magnetic fields, and also the end effector that at the end is the tiny magnetic structure that is carrying the drug.
So that's actually it's not that micro robotic, no? It's
exactly. It's a micro-robotic system because you manipulate micro or nano structures.
Great.
And they are, so you manipulate an electromagnetic field like with an MRI type of device, something similar than that, or how should I imagine the magnetic field generation you do?
So there is some people that in the past, for example, Silvan Martel at University of Toronto that use MRI to manipulate devices, but MRIs are large systems and you don't have navigation possibilities that you can have using, for example, the magnetic navigation systems that we developed with Professor Nelson at ETH, because there you can create gradients, you can create floating things, so you can pull the micron, you can create crawling motion of these devices through the musculature. We have recently demonstrated that we can put one of these magnetic devices in the brain, but through sort of a peak field and move it through the brain arteries. Facial artery, the maxillary artery, or peaks.
And so how does it look like this device? So it's conformal in the head, so that you can or
no? Right now is a modular system that consists of 3 coils. It's a triaxial system, and we use it's modular, so we can put, for example, 2. Maybe we can do 3, correct? And we put them, for example, if this is the operating bed, we have one on each side. And then we have in total 6 coils, and by modifying the current in each coil, we have a certain magnetic input. Let's say a gradient that pulls around here, or a gradient that pulls around the other side, and so on.
Does it work by the microphone? And as we were talking, preparing the interview, we said, okay, that doesn't make any sense with the current AI trends and physical AI. And you said, no, yeah, there is.
We use AI, actually. We have researchers that develop path planning algorithms, for example, to decide where the robot should go. Imagine you take the X-rays or the MRI map, or the road map, let's say, of your vasculature, and you want the robot to follow a certain trajectory, you could actually plan this trajectory using path planning algorithms. But also, I think I commented to you before, we use AI in materials design, and in these systems where we have a very tiny structure where we have to put magnetic material, drugs, contrast agents, and a matrix that holds this, AI could be very useful to optimize or find the combinations that make all these parameters, all these aspects optimal. Okay, it's a fine-tuning of all these elements, right? And there is AI a lot in material science to be implemented here.
Okay, it's the application you described about moving these robots through the veins and capillarity of humans. Is this a proof of concept? How far is it from deployment in?
So last year we managed a milestone. So we managed to demonstrate that we can move these micro robots in vivo in a workspace of a large animal. This was really the bottleneck. I think now we are pushing now to repeat these experiments towards clinical applications. So I don't think this is a very far future. I would say maybe 10 years, being optimistic, 7 years, maybe we see the first in-human trials with these devices.
All right. What about challenges, technical challenges of these micro robots?
There are many. Of course, one was the navigation, but now we are confident that we can use that and also optimize it, but also knowing how much further optimization has to be. This is a challenge and needs to be investigated. And EU puts more and more regulations in use of animals, so we need to also do other research on how to do this in cell organoids and all this. But this is one of the challenges. Other challenges is how to optimize the magnetic material inside. We work a lot on this in our lab. We managed to find an optimal material that could be in principle used for navigation, but we should not worry about reading this magnetic material in the body because we use nanoparticles that could be ultimately clear magnetic. Other challenges will be related to the tracking. So we use here a contrast station, handle now particles to fall within the brain, but in other parts of the body it may be more challenging. So it's kind of always say that this is actually a core material, right? You optimize something, but then you have worse than someone else, so you always have to find the optimal balance. And that's why I said before, AI actually I don't believe this.
My field is sensing and perception. In unfolding or in this way. How do you map the vascular system? You have a pretty understanding of where they should go, or there is like a live measurement of the position and the next
So this is done already in conventional surgery. You take a catheter, for example, imagine you have a stroke, hopefully not, but imagine you have a stroke. So usually they will see what they could do. Maybe usually you take a catheter, you inject it through the groin, you drive this catheter until the vasculature of the brain, and there you inject contrast agent, and then you see all the vasculature, right? Then you have the map, and you can do this either with X-ray fluoroscopy or MRI. In our case, what we do is to use X-ray because our electromagnets cannot be compatible with MRI system.
Okay. So you generate the map clearly, and then you
And we also do robotic catheters. That we also can do magnetic catheters that we can improve the dexterity exactly of the catheters. Right.
So you can move the paths where the robot goes. Let's say something. Great. Maybe one. Do we still have time, Miquel?
I think you have another one, yeah.
Okay. Also, one part of your research is about which materials are used for robots, not only for those micro robots, I think, but for generally speaking, where the robots are being used and which kind of materials have to be decided and developed, let's say.
So I know more about in my field in microrobotics, but I know that there is also need in other larger robots. And I think I was talking to you an example. Imagine you want to design a rover system that goes to some planet, and the atmospheric conditions are very harsh, or they for example, we use some sensors or some casing that it's unpredictable by the conditions. You also need to consider these factors, or you are using a robot that is always in mechanical service. So there is now the concept of using some materials that are self-repaired, so repairing you, and so that when there is a fracture, there is an inner component that releases some glue or some adhesive material to self-repair the material. And this is especially important if a robot has to be autonomous and has to be in service for certain time.
They're brave. We have been, we discussed with Kateryna before, like those quadrupeds going to the gas or platforms. I can imagine that's also very harsh with sea salt, water, and
not only this, imagine that you are changing terrain from something that is slippery and you didn't take this into account, and the robot, instead of actually crawling, is slippery, right?
Yeah.
So you might need to have a sensor that detects this and then change the material roughness, for example, to impart some friction or increase the friction depending, of course, on the terrain, and this is also very important. And also it's a component on changing the material to adapt up to the environment.
Okay. Interesting. You want to do it?
I mean, we could continue.
I find it very interesting, but yeah, maybe for another one.
And let's go
Salvador next time.
maybe for the last one. As a Catalan, you're let's say the second Catalan today as an interview. How do you see, let's say, the chance to go abroad? Why do we Catalans have to go abroad in order to excel in science and in industry?
I think this is a complex.
Okay.
2 years ago, I invited Professor Alicia Casals from UPC, showing how they did their surgical tools. And one of her sentences was, I developed this with 1 less in my funding. And it was really impressive, right?
1 0 less compared
1
to...
less in the funding respect, probably she was referring to here.
Okay.
And if you compare to the US, maybe it's like 2 or 3 zeros less. Huh?
Correct. Sometimes it's not only about the money. Sometimes actually there is this famous sentence that being hungry, it awakes the intelligence, right? So, so it's of course money helps a lot, but it's not everything. So at the end, the talent is everywhere, and if you push it, it might be more difficult. But if you push it, I think it's good. But sometimes we need to go abroad, not only for the question of money, is to find another point of view, another vision, get inspired by something else, and then we can return problem after these visions.
Thank you. Thank you, Salvador. Applause.
Yeah. I was so much in my job that I thought I had to go pick up another one, but you prepared it already, Martí. Cool.
That's for the awakening of the...
All right.